multi-shaders programming in Open means what we have seen by now. I have one program, and inside that I enable depth testing and we clear the buffer and so many things. That is kind of a state management. And then followed by I start drawing I compile the shader and then use the shader and whatever the vertex attribute like vertex coordinates and its normal and texture and then texture unit, lighting whatsoever. Then I just enable everything and I start drawing. So now I have in my scene, I have one more. Okay, like if I am drawing a kind of a car, then car is one, and then car will glow like this and this and that. Okay, what about car has two lights? Car has wheels. Anyway, car had wheels, but the wheel would rotate little differently than car moves, the way we see. And light would behave differently, like light would glow, irrespective of car is glowing or not glowing. Now, car is moving, and then there is a road, there are trees. Okay, so now if I bring everything in one model, if car rotates, then tree will also rotate, and so it's not possible. Having one shader, generally a program has one shader, vertex and fragment shader. Typically we never think that it is only for one object. Okay, and what about if I want to draw multiple objects? Multiple object in the sense, like anyway, I had a car and it has a wheel and it has a lighting and everything. Multiple object in the sense that all object will have different characteristics. Okay, they will move independently and they will light independently. They will texture up independently. They will rotate independently. They will react to light independently. Like typical scenery, like a man is kind of just strolling on a grass or kind of in a park. So park trees are different, man is different. If there are fountains, then they are different. So all are different. That means this is the real world. So multi-shaders in the sense that how we can go for, if I go for multiple model, for each model, now I need to have multiple shaders. So how multiple shader comes into the picture? When we, in shaders programming, when we go for doing, like if I don't have shader programming, if I go for fixed pipelining, then it is pretty easy. Means different models are there. And when one model is drawing, just push the matrix and pop the matrix. And when you push the matrix, transform your coordinate and draw yourself and just come out. And then push the matrix. So this way, model by model, we draw in the fixed function pipeline. But that is not the same in shaders programming. So in shaders programming, a multiple object, if we want, then we have to go for multiple shaders. Each shader is for one object. So that is multiple shaders. But then how, means if I have a like vertex shader, then what we decide in the vertex shader? We decide mainly the new position, new transform positions in vertex shader. And for each vertex we define the color, if not then in fragment shader, per pixel wise we define the color. Okay, so that is kind of the actual need of a vertex shader and fragment shader. Now, if I have multiple objects with multiple fragments, then everywhere position would change and everywhere coloring would change. So how we achieve it? Like when I do positioning, when I do the stuff, then I call GLUs program, and whatever my shader is, that will come into effect. And after that, whatever I do, like binding to a VAO, and then what transformation I do, so everything will go in that shader that is currently in use. At one time we use one shader, but still how everything goes in one kind of buffer that we see on the monitor. When shaders are different, all parameters are different. So if I see the frame buffer means whatever we see on the screen, that is the color buffer. Okay, but along with color buffer, other buffers are important, like depth buffer, stencil buffer, whatever work we do. And like if I go for any transformation and coloring and lighting and so many things, then we change the color buffer. But depth buffer will have, if I enable the depth buffer will have entries for each perimeter. And then depth test will arrive after fragmentation, and it will start culling whatever is hidden. So, if we talk about depth buffer, so everything goes in color buffer. But whatever the importance of the depth buffer is, like this is front and this is back. Okay. Now, first I am drawing the front, then I am drawing the back. But in actual picture, it will draw up before the front. Means whatever is drawn at the end, that will appear in the front. Means that is the actual drawing. But if it enable the depth testing, so everyone's depth is it is registered, and at the end of depth test, they will, even though I draw back side at the end, but it will go away because that is in the back side. So that is depth testing. So in OpenGL, everything depends upon the frame buffer. Frame buffer is nothing but it's a data structure that keep pointer to color buffer, depth buffer, and stencil buffer. So application wise, we maintain same frame buffer. And now, if I am drawing with one shader program, it is going to same frame buffer. I am drawing with second shader program, it is going to second frame buffer. It is going to same frame buffer. So frame buffer is same. So when I use one shader, there I do GL position transform. It will go at that location, and then it will make the drawing using fragment shader, vertex shader, and fragment shader. Now, if we use next shader, then it will go ahead and it will do drawing, and so means all shader would finish drawing through same color buffer and same frame buffer, same depth buffer. So that is same. Okay. Now after depth testing, depending upon their depth, so they will be culled. So we will achieve the whatever we want. So multiple objects. So now if I have a car, then I can afford car is different. Wheels are different. Light is different. Okay. Many parts can be different. They can be assembled together. And then wheel will have different different shader. Car will have different shader. Light will have different shader. They may behave differently if I move a car, rotate a car, or something like that. So that we'll see then. It is car is running on a road. The road behave differently. Then trees are there. Tree will behave differently. So for them we will have a separate shaders, and then every shader would get chance to execute. And so this promotes the idea of you can say like aggregation, okay, or loosely in aggregation or composition. Okay, so like a car can compose a wheel, or in aggregation, a wheel we can provide from outside, but car contains a wheel, so transformation and those things will propagate through. So good designing comes into the picture. Now I can have a ready-made car model, where from outside, like it comes under design pattern called flyweight design pattern, where we have intrinsic and extrinsic, and from extrinsic we can kind of push a new wheel and new light, and then it can start behaving. So I can just create many models and keep in a library, and ready-made I can use whenever we want. So multi-shaders or multi-model, how we draw and how we can use efficiently, because like if I talk about electronics, then power of electronics is its speed. Okay, there is nothing special about electronics, but the way it has changed the things because of its speed. Like that, if we have a GPU, it has speed of calculation. So, if speed comes, then means design to everything changes. So, we cannot live in the same world. So, things would change. Now, we have GPU and now we have fast moving objects. So, we cannot go for fixed function pipeline. So, how we will manage GPU against various models and multiple shaders, their transformations, and then their material use, and then their lighting, and so many things. This much complexity, how we can make life easy. We'll continue on desktop. This is Linux Mint. Okay, so briefly, this multi-shader is developed in kind of various phases. So whatever we can show. Okay, so a frame buffer is a data structure, and this data structure keeps color depth and stencil buffers. Color buffer, depth buffer, and stencil buffers. Okay, so color buffer can be filled with various shapes, and shape buffer has an optional entry. So shape has an optional entry into the various depth buffers. Okay, so shapes has entry into okay, so color buffer can be filled with various shapes, and shapes has an optional entry into depth buffer. So depth buffer can exist or it may not exist, and we have talked about the analogy of the depth buffer. If depth buffer is not enabled, whatever we draw, so that will come at the front. So that is problem with the depth buffer. So like if someone is drawing and he is drawing a circle, okay, and then he is drawing a rectangle, but rectangle coordinates are behind. Okay, so but if depth buffer is not enabled, rectangle would come like this. It doesn't know what is the depth of this rectangle. Okay, so that is so those information it keeps. So even though we draw the rectangle after we draw the circle, ellipse, but since it has more depth, so it will go kind of behind the scene. So this would be the kind of actual drawing, even though I draw a rectangle after the circle, but since a rectangle has more depth, so finally it will come as this. So depth buffer has importance, but it is optional. We can set, we cannot set. And why we don't set? So that has kind of importance. And many places we don't need depth buffer, like transparent. If we are drawing transparent shapes, then we don't need a depth buffer. Okay. So whatever is drawn after, so that we need to come at the front. Unnecessary computation in the depth buffer. Okay, so multi-shader programming fills some color buffer, same color buffer and depth buffer through various shaders. Okay, so this is a panoramic view. So frame buffer keeps a color buffer, depth buffer. Mainly it keeps a stencil buffer also. Now there are many shaders. One shader keeps many VAO. This shader also keeps its own VAO. I would rather say it's a composition rather than aggregation. Okay, so this is kind of composition. This is also a composition. Okay, now these are kind of attributes typically, and shader also keeps pointer to uniform variable, and they are generally projection matrix and model view matrices. So each have their own pointers. So when this shader gets chance, so this typically happens with GLUse program. So there is an API that hooks kind of, someone can just call like okay, so GLUse program and passing the ID of the shader. If that is called, then that particular shader comes into the effect and that writes on the color buffer. Okay, so each shader gets chance one by one to write on the color buffer. So it is same shader is writing on the color buffer, but if you use GLUse program for different shaders, then different shader one by one they get to write on color buffer and depth buffer. And since they manage different VAO, different uniform variable, different vertex shader, different fragment shader, complete settings are different. Only common thing is at the end they dump their coloring here. Okay, so anyone can dump their coloring depending on the kind of coordinates. So since color buffer and depth buffer is same, so it can be considered as kind of they share the screen. If this is the window, okay, so indirectly, not directly, indirectly, it would be considered as they are kind of sharing the screen, same screen, indirectly, not directly. Okay, because this screen is directly coupled to color buffer. Okay, so probably this is clear. Okay, so we will write. We have a ready-made code. Probably we can demonstrate it later. A shader, and which manages between VAO and so many things. So we will use that, and then we will kind of draw various shapes. Okay, so in lab session we will have like this. So what is multi-shaders? These wheels, can we see? These wheels are different shapes. It is attached differently, and this is a whole car. Okay, later we'll bring the lights also. Right now it is just white, but the light is not there. And wheel has its own movement, car has its own movement. They are attached to each other through various shaders. And then they will move together and they will show their characteristics. So that is the idea. So we can start. Okay, so we'll create a directory called GLSL MultiShader. It's empty, and we will copy the skeleton code. So that much probably will not write. So copy GLSL. So skeleton code, like it begins with, I can say like FGL multishader.py, and it starts with from OpenGL.gl import everything, from OpenGL.glu import everything, from OpenGL.glut import everything. So it's like that. Then we'll have depth init, depth display, okay, depth reshape, and then initialization code. Okay, so we'll copy those things. Okay, so that is the idea. So probably we'll copy from whatever we have developed last time. So we'll copy it. Okay. Now we have only one file. Okay, so we will edit this template. Okay, so probably these we'll edit. So this much we don't need. So we'll have init. And then we'll have shade model smooth, enable display, translate to kind of 15, it's okay. Okay, so done. And then we'll have kind of swipe buffer, and then we'll have a GLU perspective. Kind of angle would be some 30 and to 30, or since this is a car, we'll make it 50, 15, and model view. Okay, we'll leave keyboard like this. Okay, we'll change it or we'll remove it altogether, not required. We'll remove it altogether. Okay, so we'll write. Okay, so pretty simple. There is nothing, just to avoid writing, typing. So init has clear color shade model, and we enable depth test. So post a kind of rasterization, we have fragmentation. Fragment color would be come into the picture, and then means fragment shader. Beyond after that, post that, depth test will be performed. Now we have depth buffer width, and we have set glut swipe buffer, and viewports we have set, and projection. For all this you can refer other tutorial that is in fixed function pipeline, and then projection identity, and then load identity, and here we have used double and 500 and done. Okay, so we will fill it. Okay, so in it will fill. So here we'll have kind of from shader. So as we told, we have a shader class that does shader, means it is a local local class. It is not global class. Okay, and then we'll have kind of shader I equal to none, and I would say global shader I. So we are free to do on shader I. So shader I equal to shader, and it requires ops file. So every shader has a ops file. So I would say there is no ops file. This is the top class shader file. Okay, it will contain many things like loco2. Loco2 is nothing but the car or the locomotive that we are showing here. This is loco. So loco, and then we have wheel. Okay, so these are the file we'll copy. Wheel2 equal to wheel. Okay, now we'll do kind of shader I dot add. So this is a top level shader. In that we'll add object as loco2, and we'll fill fix transformation as 90. Will tell what it is. Okay, so fixed transformation is like whatever we generate through Blender. So it comes as a kind of a pre-made, factory-made orientations. So we kind of change it in a kind of certain orientation we give as a fixed. So this much will happen always. Loco2 dot add object is equal to wheel.mtl. Object equal to wheel. So wheel object. So wheel2 would contain in the constructor. Okay. Fixed transformation. It has a big fixed transformation. Minus 2.4 minus 0.1 1.25. Okay, this is kind of a translation. There is a scaling also. 0.1, 0.1, 0.1. So this big is. And then there is a fixed rotation, that is 90, 1, 0 and 0. Okay, so this is how it is. Okay, slowly everything will be clear. So there is nothing kind of highly hidden here. Now we'll add loco2 dot add. So we have added wheel 2 with fixed transformation minus 2.4 minus 0.1 and 1.25 and S 0.1, 0.1, 0.1, 90, 100. Okay, so I'm not going to type it. So we'll just copy paste 4 times. So loco has 4 wheels. Object is same wheel. We are not going to create different objects. Otherwise it will eat our GPU badly. So I am not that rich. Okay, so it is look. Can we see why I am changing this? So these are 4 wheels and they are getting attached at different location in the car. So that's what I am doing, fixed transformation. So there where they will get attached. And then 1.25S and 990. Okay, so everything is same. and this meter would change. So minus 2.4, 0.1. So this will go in rear. I think it's clear. Okay, this is front one, and this would go in rear. Okay, so we are done. We can push other characteristics. So probably we'll do it later. So this much is okay. Okay, we'll jump to display, and after doing this, so we'll say shader I dot display key equal to whatever key is pressed, and pop matrix. Okay, so we will fill much needed keyboard function. So I think it is become keyboard func, and it will become keyboard, and here we'll add def keyboard and key and other parameters we get through this. Global is count and key press. So we'll add count and key press as global. So I will say count is 0, and where key press is none, nothing. Okay, so if key equal to, okay, we make sure that key is byte because all processings are happening in byte. Now if key equal to tab, then we are switching the, okay, so count equal to count plus 1% len shader I children. So it has children as various cars. For I in range len shader I children, shader I dot children, whatever is. Okay, I believe we don't need this. Okay, so time being we can just omit this. Okay, it is not that difficult. So util I dot keyboard key dot shader I dot children count information. Okay, so I believe we can just leave it like this. Key press equal to bytes of the key. So anyway, it's okay. So it will be key clut post re display. Okay, we'll not leave it, we'll add it. If key equal to, if we want verbose print, then we can say like okay, so print f whatever is I and shader I children I transformation equal to. Okay, so for I in range len shader I children. Okay, so I believe it's nice. Okay, so whatever shader right children we have for that transformation, typically we can print other attributes. Okay, so what is pending is we have to initialize the. Okay, so there are many things like what is util C. So shader already has util I. Okay. So I can say util I equal to shader util I. So we get the util I, otherwise we have done everything. Okay, so we have imported. Now we'll copy those files. Copy shader.py here. Wheel.py here. Loco.py here. car2.obj. car2.material file. Wheel.obj. Material. Will copy some color file also, like red.png and blue.png, green.png, yellow.png. Okay, so now we carry these many files. What is required? So I believe I can try executing it. Oh, it came. Okay, so car has arrived, just new car. Okay, but it is not rotating. Okay, so we have to pass key and then children transformation. We have done this many times. So whatever shader right children count is, that count we have to pass. We'll try again. If it really rotates, it rotates. Okay, but wheels are not aligned. This is what I can see. Okay, so wheel coordinate need to be verified. Okay, fixed transformation minus 2.4. So if it is not, then probably angle is not correct. So it will be other way. Okay, I believe it is done. We can bring the car near. Okay, and if we can see the wheel is rotating. Okay, it's not that we have placed something that is fixed. So wheel is rotating. If I bring it back, wheel is rotating. It is really a car. Okay, it is really a car. Okay, what we can feel now. So this is not a kind of some enigma that we are typing in. So shader is a program that kind of it manages various shaders, and loco are derived from shader, wheel is derived from shader. So everyone maintains kind of vertex shader and fragment shader, and then we have a guy called shader I, and shader I is a kind of container shader and which has no object file, and this loco and wheel, if I see their constructors, okay, so in the we can put all this addition of the wheel in the constructor itself, but for demonstration I have put, so it should be kind of more containment. So in the constructor we have calling car.obj and wheel, we are calling constructor wheel.object, and it is handling few events. So that is this is local code, means this is not we have imported from anywhere else. And if we see this, whatever we have written, so in the def display, we call the top level shader display, and internally recursively it calls car, and then car contains wheels. So okay, so first also, so the top level containment we create, then we add the loco to the top level containment, and loco to loco we add all the wheel. How wheel would be placed? So one example I can show. Like I can just disable it. Okay, probably I can disable it. One example I can show where I want to put a fixed transformation. Okay, so I can just say it's enough. Just add a wheel. Okay, what it would do? This is wheel, this big. Okay, this is initial we have received from the blender. This is car and wheel are together. So this is the actual wheel that we have received. Now we are, okay, so this is actual wheel. Car and together. Okay. So this is the wheel. Now what we are doing is, to the wheel, we are adding the wheel and we are doing transformation like it. We are doing translating to some location. We are scaling to 0.1, 10 times down, and then we are rotating to in a way that would fit as a wheel. Okay. Can we see? It is fitting as a wheel, a real wheel at that occasion. So we scaled, we translated, we rotated, and it is really a wheel. And other wheel we have not placed. So if I remove this addition also, then there won't be any wheel. Okay, so probably that's okay. Now we can add other attribute also, like what would be its color and those things. I can say other attribute is OpenGL and material dot diffuse. Everything kind of can be referred in the texture and lighting shaders tutorial. Okay, so material dot diffuse is green, or I can place it red, no one can stop. Okay, now, so this is a hash, dictionary. Okay, change. No. Wheel has many kind of okay, so center axle is different, and it has tire is red, and like that. Okay, we'll add various things. So if I move this, then wheel would rotate. I believe wheel rotated. Okay, so rotation stuff we have put in the wheel class itself, and there it receives the event, and then it does the transformation locally for the wheel. Okay, now we can add more things. Okay, so probably we can copy paste and we can add. It's not a good way to copy paste. We can type in. Okay, when it is in my hand, I can give various colors. Okay, now car is really a different kind of car. Okay, so where now we can see the axle. Means it is really this side, that side, all are nicely fitted. It's really a car. All wheels are rotating. Okay, so I think we are done. If a road is like this. Okay, so we can kind of zoom in. Any part we can show nicely. So this is grand coordinate kind of rotation. So we can really see the car the way we want. Okay, so Mr. Car is again back, and then it is ready to move. Okay, so it went. Now we can add more car. Okay, so I can add like this. We have 5, I believe. 5YY. Okay. Same object is loco 2, And here, okay, I would rather say, I believe, okay, this is angle, to translate would kind of precede the angle. So I would rather say kind of go to 4, -4 or -3, -4 will try, and 0 and 0. So we are kind of locating the car, where car would go. Okay, and here I can just say that go to kind of 4, 0 and 0. Okay, so we have added to our shader model. People call it scenery also, but it is far kind of advanced. And this is kind of we have added 3 shaders to each shader we have added. Now, can we see the classic? We have only 2 objects, loco and wheel, and then we are making so many. Okay, so that pressure would not be on the shaders. Oh, we have 3 cars, and if I can move one, okay, wheels are rotating for everyone, so that will take care. Okay, so it would rotate, and it is ready to go. What about next car? Okay, this is software. Okay, what about this car? So this car ready to turn. Okay, we have not forgotten our old car. So no one can stop us, this car, to come back. I believe it will collide. So it can come smoothly. Okay, I'll try changing the color of wheels if it is possible right now. So I'll make it opposite. So now it is red. So this one I'll make it kind of red, yellow, yellow and red. Let's see if it is like that. It works. Red, yellow, yellow and red. Okay, so probably this need to be taken care. Okay, so this much it does. So we tried adding loco and then material diffuse to different color. So if I set this to blue, yellow, blue, yellow. Okay, so right now it's not possible. So this much is developed, okay, locally. Okay, good thing is we can rotate the way we want in global axis also. Okay, so I think it's enough. I think we have really tilted it. Okay, I believe it's okay. Okay, so this car gone. Okay, so this is kind of a multitasking where we have a wheel and car separately, and then they are moving. Okay,